Thank you for giving me the opportunity to convince you that supporting the AUGURY project would enable a transformative step in the study of the solid Earth. I am Nicolas Coltis, and I've been leading educational and research projects in geosciences for 10 years. I played an active role in the convergence of geochemical and geophysical representation of mental dynamics, at a time both communities were confronting each other. I also contributed to put new perspectives on how the solid Earth has slowly shaped the surface environment billions of years ago. In recent years, I participated to make great progress on how continental drift and mantle convection are linked together. I enjoyed these experiences because I had to find ways to build bridges between geodynamic modeling and observational disciplines. But now, I think with the AUGURY project, I have the opportunity to push integrations of models and observation in my field to a new frontier. The AUGURY project is designed to open the way to go beyond plate tectonics. Plate tectonics is almost 50 years old, and it is one of the great theories in our discipline. It combines geometry on a sphere with multidisciplinary data to produce tectonic reconstructions. However, tectonic motions are the surface expression of mantle convection. Indeed, mantle convection is a more complete theory than plate tectonics, linking the surface to the interior and avoiding the assumption of perfectly rigid plates. But in practice, convection models have mostly failed to generate surface tectonics that compares to the Earth. So the shift from plate tectonics to mantle dynamics has not been realized yet. But last year, with Tobias Wolff and Paul Tackley from Zurich, we have made a fantastic breakthrough. We have designed for the first time mantle convection models that successfully generate surface tectonics comparable to the Earth at first order. It was exciting to produce with one single model a tectonic and a convection evolution. It was the major step we needed. I want now to combine our new generation of models with advanced datasets to reconstruct jointly past tectonics and convection history. The conceptual framework to realize this goal is data assimilation. Scientists in climatology, atmospheric and ocean sciences or geomagnetism have set data assimilation as a cornerstone in their field. I want to walk in their footsteps, using data assimilation to make a quantum leap in the study of the solid Earth. The AUGURY project will change not only perspectives on the deep Earth, but it will provide innovative tools and new information on fundamental issues of Earth sciences. My strategy is to work with my team on 4 complementary tasks. The first task is to define the framework of use of our data assimilation. We need to know the predictability limits of our convection models. With task 1, we will develop a low-cost, high-reward approach to reconstruct mantle convection using seafloor edge grids and surface motions as the data to match. We will develop a generic Kalman filter approach, which is straightforward to implement. We just produced a proof of concept for this innovation with a master's student this spring. With task 3, we will develop a high-end approach to produce for the first time joint tectonic and convection reconstructions. We need to build a unique variational data assimilation code. Development of this code is challenging because I want it to be sustainable, automatically updating improvements of the convection code. To succeed, I will work with FastOpt, the world-leading company for automatic differentiation and variational data assimilation. In the meantime, with task 4, I will disseminate results, data, and teaching material through a data hub accessible online for scientists, teachers, and the public. Proof of concept and privileged partnerships with the reputed groups of Sydney and Zurich are already there. The only thing I need to start is financial support over 5 years to contract FastOpt, recruit my team and operate, and acquire computing flexibility and autonomy. The AUGURY project will provide methodological foundations and produce groundbreaking results for the community. It will give young scientists the opportunities to contribute to cutting-edge science and to get embedded in a multidisciplinary and international project, including exposure to non-academic research, and to build, within my team, a transformative European success in geosciences.